Betelgeuse's secret companion finally revealed. Betelgeuse, the bright red star marking Orion's shoulder, has been hiding a secret. For over a century, astronomers suspected it wasn't alone, and in 2025, they finally found the proof. Betelgeuse has a companion star. But this isn't just any discovery. The companion, nicknamed Betelbuddy and officially named Siwarha, is so close to Betelgeuse that it's literally orbiting inside the supergiant's outer atmosphere. And its existence is forcing scientists to rewrite everything they thought they knew about this famous star. The challenge. Finding a companion star next to Betelgeuse is like trying to photograph a firefly hovering next to a car headlight. Betelgeuse is a red supergiant, roughly 700 times the size of our Sun, and thousands of times brighter. It's so massive that if you placed it where our Sun is, it would swallow Mercury, Venus, Earth, and Mars. Any small star nearby would be completely washed out by Betelgeuse's overwhelming glare. The brightness difference between Betelgeuse and this little companion is absolutely insane, said Anna O'Grady, a postdoctoral fellow at Carnegie Mellon University. The fact that we can now confirm something is there shows how far our science has come. The race against time. For decades, scientists analyzed Betelgeuse's light, its wobble, and its variability, looking for clues. Two 2024 studies examined over a century of observational data and predicted that a companion star should exist, orbiting Betelgeuse every 6 years at a distance of just 4 astronomical units, closer than Jupiter orbits our Sun. But predicting it and seeing it are two different things. The breakthrough came in December 2025 when Siwarha reached its maximum separation from Betelgeuse, a fleeting cosmic window that happens only once every 6 years. Researchers had just days to act before the companion disappeared behind Betelgeuse for another 2 years. O'Grady's team secured director's discretionary time on both NASA's Chandra X-ray Observatory and the Hubble Space Telescope, time reserved only for the most exceptional research opportunities. The fact that both proposals were approved simultaneously speaks to how significant this discovery was. And it worked. Using Hubble's UV spectroscopy and Chandra's X-ray imaging, the team detected Siwarha's wake, a trail of dense gas swirling through Betelgeuse's extended atmosphere as the companion plows through it. Meanwhile, another team, led by Steve Howell at NASA's Ames Research Center, used the Alapeka Speckle Imager on the Gemini North Telescope in Hawaii to directly image Siwarha in July 2025. There it was, a faint blue-white pre-main sequence star, about 1.5 times the mass of our Sun, sitting right where the models predicted. What this means? The discovery of Siwarha solves some of Betelgeuse's biggest mysteries and creates new ones. First, it explains Betelgeuse's 6-year brightness cycle. For years, scientists knew Betelgeuse dimmed and brightened on a roughly 6-year pattern, but they didn't know why. The 2019-2020 Great Dimming event made headlines when Betelgeuse lost about 2/3 of its brightness, sparking speculation that it might be about to explode as a supernova. Now we know the answer. Siwarha's orbit periodically clears away light-blocking dust in some areas and causes it to accumulate in others, creating the brightness variations we see from Earth. But here's the puzzle. Siwarha is an A or B type star, hot, young, and blue-white. It hasn't even started hydrogen fusion in its core yet. It's a pre-main sequence star, still in the process of becoming a full-fledged star, and it's orbiting a dying red supergiant. The mass ratio problem. Binary star systems usually form with stars of similar mass, but Betelgeuse is 16 to 17 times the mass of the Sun, while Siwarha is only about 1.5 solar masses. That's an extreme mass ratio and one of the most lopsided binary systems ever discovered. This opens up a new regime of extreme mass ratio binaries, O'Grady said. It's an area that hasn't been explored much because it's so difficult to find them. How did this system form? How did a tiny companion end up so close to a supergiant? Scientists don't have good answers yet. The future. Betelgeuse and Siwarha won't stay together forever. Betelgeuse is nearing the end of its life. In cosmic terms, it could explode as a supernova anytime in the next few 100,000 years. When that happens, Siwarha will be caught in the blast, a front-row seat to one of the universe's most violent events. But there's another possibility. Siwarha may not survive that long. At just 4 AU away, it's so close to Betelgeuse that tidal forces are already pulling on it. Some scientists estimate that within the next 10,000 years, Siwarha could spiral inward and be consumed by Betelgeuse entirely. If that happens, it could affect Betelgeuse's evolutionary timeline, potentially triggering the supernova sooner or delaying it. The discovery also raises new questions about other red supergiants. If Betelgeuse has a close companion, how many other variable supergiants might have hidden partners affecting their brightness? Astronomers are already re-examining data from other stars, looking for similar patterns. The next observation. Siwarha is currently behind Betelgeuse, from our perspective, hidden in the glare. But in 2027, it will emerge again, reaching maximum separation. When it does, astronomers will be ready with even more powerful instruments, ready to learn everything they can about this remarkable companion. For now, the discovery of Siwarha reminds us that even the most famous, most studied stars in the night sky can still surprise us. Betelgeuse wasn't alone. It never was. Like, share, and subscribe for more cosmic discoveries. And as always, keep looking up.